Today I'd like to talk about geometric distributions, so please open up your study guide to the geometric distribution section. Let's begin by talking about the properties of a geometric distribution. First of all, there are always two mutually exclusive outcomes. Each trial is independent of the others. The probability of success remains constant for each trials. Now, if you notice above, these three properties are identical to the binomial distribution as well. The random variable x in a geometric distribution is the number of trials until the first success occurs. Geometric probabilities are sometimes referred to as first success probabilities. When will my first success occur? That's what we're asking in a geometric probability question. Notice the notation, the probability notation for a geometric distribution. If my random variable x has a geometric distribution, we denote that with x followed by the tilde symbol and a capital G. Now, only one parameter is required for a geometric distribution, and that is the probability of success. In this case, the probability of success is 0.3. So this notation means that my random variable x has a geometric distribution with parameter p equals 0.3. One noticeable difference between the geometric distribution and the binomial distribution is that in a binomial distribution we have a fixed number of trials. In a geometric distribution, we do not. We are only considering the time until first success. So let's compare once again the differences between a binomial and a geometric distribution. Now, the difference between binomial and geometric properties is there is not a fixed number of trials in a geometric distribution. Once again, there is not a fixed number of trials in geometric distributions. And in a binomial distribution, there is a fixed number of trials. Another difference is the binomial random variable starts with 0, while the geometric random variable starts with 1. And recall the difference. In a binomial distribution, we're looking for the number of successes out of a certain number of fixed trials n. We could have 0 successes out of n trials. That definitely is a possibility. However, in a geometric distribution, we're looking at number of trials until we achieve first success. Now, obviously, we begin with the first trial. We don't begin with the 0 trial, we begin with the first trial. Is there a success? If not, continue to the second trial. Is there a success? If not, continue, so forth and so on until we have achieved our first success. In a binomial distribution, we are looking for a certain number of successes out of a fixed number of trials. Therefore, binomial distributions are finite. And the finite distribution will go from 0 all the way to n, the number of fixed trials. In other words, the sample space for a binomial distribution is s equals 0, 1, 2, all the way through n. We could have 0 successes, exactly 1 success, 2 success, so forth and so on, all the way till we get to n, which is denoted as the number of trials. However, in a geometric distribution, we are looking for the probability of a first success. This may never occur. Therefore, geometric distributions are infinite. We may never achieve a first success. So in a geometric distribution, the sample space is given by s equals 1, 2, 3, so forth and so on, possibly all the way up to infinity if we never do achieve a success. And recall that in a geometric distribution, we're looking at the trial in which we receive the first success. Now let's take a look at the density formula for a geometric distribution. In a geometric distribution, recall, we are looking for the probability of a first success. Suppose the probability of a success is 0.2. So there's a 2/10 chance that we're going to have a success. Now, a geometric variable x can be defined as the number of trials until a first success occurs. Suppose we want the probability